Good morning, sir. My name is D. Sai Charan. Today, our topic is differentiate between cohesive and cohesionless soils with respect to shear strength. This is our topic differentiates between cohesive and cohesionless soils with respect to shear strength. First of all, introduction to soil types. Soil types are broadly classified into cohesive and cohesionless soils based on their particle characteristics. Understanding their differences is essential for geotechnical engineering applications. Shear strength is critical property influencing the stability of soil structure. Here we can see the cohesive soils. Fire-grained particles are closely integrated and stick together. Particles size ranges between 0.06 mm or less. The level of cohesiveness depends on the size, shape, and water level. When it is wet if and soft, and when it is dry, it becomes hard as high level of moisture content. The increase of water level can cause soil stream difference. Therefore, the depth and foundation should be at least 1 mm for the earth surface. Definition of cohesive soils. Cohesive soils are those that exhibit significant internal bonding between particles. They are often composed of fine-grained materials like clay and silt. These soils can retain their shape and resist shear force due to their cohesive properties. Cohesive soils are categorized by very small particle sizes where surface chemical effects predominate. They are both sticky and plastic clays. Organic soils are typically bony, crumbly, and compressible. They are undesirable for supporting structures. Definition of cohesionless soils. Cohesionless soils are consist mainly of granular particles with little to no bonding. Examples including sand and gravel. They rely primarily on frictionally resistance for shear strength rather than bonding. Fire-grained particles are closely integrated and stick together. Particle size ranges between 0.06 m or less. This level of cohesion depends on the size, shape, and water level. When it is well, is soft, and when it's dry, it becomes hard. Has a high level of moisture content. Always experience shrinkage and extension process. The increasing of water level causes soil stream differ. Therefore, the depth of the foundation should be at least 1 m for the earth surface. Particle characteristics. Cohesive soils are fine particles that are flat and plate-like, promoting cohesion that through electrochemical bonds. Cohesive soils have coarse, angular particles that interlock and generate frictional resistance. The particle size and shape significantly influence their shear strength behavior. Cohesive soils are characterized by very small particle sizes where surface chemical effects predominate. They are both sticky and plastic clays. Organic soils are typically spawny, crumbly, and compressible. They are undesirable for supporting structures. Shear strength in cohesive soils. Shear strength in cohesive soils depends on the both cohesion and internal frictional angle. The shear strength can be expressed as sum of cohesive forces and normal stress multiplied by the friction angle. Cohesive soils can develop shear strength even without any normal stress applied. Here we can see the shear strength of cohesive soils formulas and its explanation. Shear strength in cohesive soils. Shear strength in cohesive soils reflects primarily on friction between particles. The shear strength increases with normal stress governed mainly by the frictional angle. These soils do not have sufficient cohesion and thus are more sensitive to changes in normal load. Shear strength behavior under loading. Cohesive soils tend to exhibit a gradual increase in shear strength with increasing normal strength. Cohesive soils show a linear relationship between shear strength and normal stress. The difference influences how each soil type responds to foundation loads or stability conditions. Particle implication in engineering. Cohesive soils are stable, sustainable for constructing foundations that require retaining walls with stable shear strength. Coastal soils are often used in granular fill and impermanence due to their drainage properties. Proper understanding of shear strength helps in designing safe and economical geotechnical structures. Here we can see the cohesive and cohesive soils. It's like sand and red soil. Summary of key differences. Cohesive soils have significant internal bonding while coincident soils rely on friction. Shear strength in cohesive soils is influenced by cohesion and frictional angle. In coincident soils mainly by friction. The behavior under load, stability and engineering applications vary considerable based on these properties. Conclusion: differentiating between cohesive and cohesional soils is fundamental in geotechnical engineering. Shear strength characteristics guide engineering in designing stable foundations and earthworks. A true understanding of these differences ensures safety, efficiency, and longevity of soil-based structures. Shear strength of soils. Cohesion. Cohesion C is measure of the forces that cement particles of soils. Dry sand with no cementation, dry sand with some cementation, soft clay, silt clay. Thank you, sir, for giving me this golden opportunity.